Hi, welcome to this demonstration about the standard error of the mean, also known as the standard error of the sample mean. So we know the formula is the standard deviation divided by the square root of the sample size. Let's move to the simulation in the R script. In this example, we imagine a population with a mean of 100 and a standard deviation of 15. This aligns with IQ. Now imagine that we're doing a sample size, a random sample from that population of 30. 30 adults are being sampled in this case. Let's just run this once and look at what type of sample mean we get. Will it be 100? Will it be a little below or above? Let's see. Okay, we get a sample mean of 99.29. So we're a little bit below, in this case, of the population mean. All right, let's do it twice and have a look at the sample means that we get. 99.29 and 102.68. So first is under, second is over. Let's do that a few more times. Let's do it 10 times. So we're running 10 samples of 30 from the known population. Sometimes above, sometimes below, but around the true population mean of 100. We can see that it's graphed here. Let's move to 1000 and watch the distribution of sample means grow in the graph. As we can see, most of the sample means are close to 100, which is what we'd expect. Some are below, some are above. We can see that it's kind of starting to develop a bell shape, although it's a little distorted at the moment. But as we continue to take samples from that known population, it begins to take on the bell curve or normal distribution. Eventually, this becomes normally distributed, and we can see the pattern emerge, whereby the standard error of the mean, the theoretical one, which is 2.74, actually occurs. So remember, it's just like a standard deviation. 2 steps above the mean gives us our 95% confidence interval. And 2 steps below gives us our 95% confidence interval. So in this case, 5.4 would be close to our 95% upper and lower confidence interval above the mean. And this looks like it's the case, right? 5.4, or 2 standard errors above and 2 standard errors below. And that was with a sample size of 1,000. Sorry, repetitions of 1,000, a sample size of 30. Let's bump up to 30,000. Let's go to actually 50,000, and we can see what type of profile of results we might get. So that's done, and here we have it. So we can see that the result is actually what we would expect. So when we are reporting the mean of our study, we should also report the upper and lower confidence intervals of that mean, which represents 2 standard errors above and 2 standard errors below the mean. In this case, with a, was it 50,000 replications, we can see that we begin to find exactly what we expect In some cases, we are above, in some cases, we are below, and the standard error of the mean is the standard deviation divided by the square root of the sample size. Here we see 5.4 above the mean, and here we see 5.4 below the mean, represents this 95% confidence interval. Okay, so I hope that helped. Thank you for listening.